Okay, so first we will check the conditional statements, okay? So these are just like the if conditions, which we have seen before. So if we take a look on this flow chart, the selection is like a fork in the road, which allows your programs to decide which path to take. So the if-else statements allow programs to perform different actions based on the conditions. An example here could be the age, right? So if age is larger than or equal to 18, which means for adults, right? So it is regular price. Else, we give a discount, okay, for non-adults. Okay, so here the code decides if a discount should be applied based on age. Now, William, Wesley, what's the output when age is 20? That's right, yeah, regular. Okay. All right, so, and then here, William, what is the output when age is 16? Right, discount. Okay, now here, match the output with the comparison operation when age equals to 16. Wesley. You are on mute. Right. Right. The second one is true. Good work. This one seems pretty easy. Now, William, this one, when age equals to 18. Okay. And false. Okay. Okay. If we check again, that's good. Okay. Next, if conditional statement starts with the keyword if, followed by the condition and a colon symbol. Okay, Wesley, let's complete this. That's right, yeah. The other part is the statement here, they needs to be indented. Okay. All right, we've reached 5 in a row. Okay, this one, William, the code indented below the else line is executed when the conditional is not met. So this one is just, yeah, it's really just filling the blank. Awesome. Okay, this one we already know. We just jump quickly. Now, if we look at this print statement, okay, after the computer has finished executing the if-else statements, it will continue to execute any following statements in sequence, which is this line, okay? So after the if-else has finished, this line will always get printed out because it's not indented. Okay. All right, so this one, Wesley, what will the code output? Yeah, so it will, right, because age is larger than 18. And also the last line, it will always get printed out. Good work. Okay, William, what will the program output? Here, it's just a flow chart. Proceed to pay. Okay. Anything else? Age is 16. Are you able to see this chart? The content? Oh, okay. Will it print out anything else or not? Discount. Okay. And regular price? Why does it not print regular price? I'm just asking. You just need to give a reason, give an explanation. So why will it not print the regular price? Can you explain that, William? Because that's true. And what? You use the for statement. Why will not the regular price get printed out? How would you explain that? How would you describe that? Do you have any thoughts of idea? Just need to use simple words to explain the facts. How about the discount? Why will the discount get printed out? Because what is false? Give the use the for sentence. Discount. Can you elaborate more? Start from the beginning. Okay, there are the age and why is it what leads to false? Okay, that's why it comes to a false, which will make the discount printed out. Okay, and right. And Wesley, why will the regular price not get printed out? Mhm. That's right. Yeah. So therefore, the path will it goes through the false, and then it will print out the discount and proceed to the payments. All right. Good work. Okay. Here, select the symbol that will make the operation result in true when age is 20. Wesley, which one would be correct? So if we double check, okay, it will make the operation result in true when age is 20. Yeah, this one means not equal to, okay? And this one means equal to, yeah. So the first one is comparing. So 20 doesn't equal to 18. So the first one will lead to false. And the second one, this one, it will lead to a true. Okay. And if we are not sure, we can definitely try something, right? So if I just add a code cell in the collab, right? Let's say age equals to 20, and if we try double equal sign, right? Age double equal to 18. So here, we'll note that here it's doing comparison, okay? And when we run it, so notice that it's running, right? So here it will print the false, but if I change it to not equal to, right? So this time it will return true, okay? Because 20 doesn't equal to 18. Okay. Okay, if we continue here, select the symbol that will make the operation result in false when age is 18, William. So select the symbol that will make the operation result in false when age is 18. Okay, Okay, all right. So make sure you read the question carefully, okay? Okay, so here you can build programs that make more complex decisions if you combine logical and comparison operations. Select the logical operation that makes the combined expression result in true. So is student equals to true and age equals to 20. Now, Wesley, which one should we pick to make the combined expression result in true? That's right. Yeah. Or because age is smaller than 18, it's here is a false, left side is a true. So to make the end result to be true, we need to use an or condition. Okay. Right, exactly. For and, we need both to be true for the end result to be true. Okay, William, what will this code output? Can you explain why it is true? False and true. So false and true, what will it lead? False and true. And why is it false? Okay. So wait a second, okay? Can you repeat? Is student is false, and then this one is what? 16 is smaller than 18. Okay, this is the smaller sign. Okay, so false and true, and that becomes we know that just as what Wesley said, right? False and true, and is combining, right? So it will end up with false. Okay. All right. So here we'll pick false. Okay. Okay. For this one, we already know. So let's skip. Okay. So this one, Wesley, what will the code output? You are on mute. That's right. Yeah, it will be discount because the is student is true. Okay. All right. Yeah, that looks like straightforward, but still a little bit tricky conditional statements. Okay, now let's move on to some other areas. So let's take a look on the coding adventure again. Who's in for a banana split after this is over? All right, let's see. So here we have a loop here for being bananas. If b dot green, say this is for you, goat. Else, say that's mine. Okay, Wesley, you can give it a try. Mhm, mhm. 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 Okay, 1 second. Uh-huh. Right. Okay, now at the beginning, okay, so regarding the weight, let's see what would happen, okay, if we use an if here. Note that for the weight, it needs to be something constant. So, and if we look at the word here, right, we have some other conditions, right, other than if. But let's see if we do an if here. So if, yeah. So here we need a constant, we need a continuous action. So here we want to, it's like we don't just want to wait a moment. We want to keep waiting, okay? William, please get really focused, okay? We want to keep waiting until Tiger is sleeping or playing, okay? So until Tiger sleeping or Tiger dot playing. So either of the condition, okay? And then here we want to do a wait, okay? So this is basically saying that we will wait until Tiger is sleeping or Tiger is playing, okay? And then we can decide which banana to pick. Okay, so if I try to run it, okay, so did you get into an infinite loop? Let's see. Okay, so let me click that rewind. I mean, keep trying. Okay, and here let me. So I was missing a bracket earlier, and let me try again. Okay, Tiger is playing. Okay, Tiger is playing again. Okay, yeah, that's a banana ice cream. Okay, so there are two of them, and give me a moment here. Okay, so here for being bears, it says wait here for B to sleep or play. Okay, so William, give me your thoughts. Uh, I'm sorry. If okay, we were just discussing that in the last round, right? So, but let's see. You were saying if B dot sleeping or I'm sorry, just sleeping. B is in the bears. So bear sleeping, B dot sleeping, that looks fine. So what's before or after? well, what I'm saying is number line 3, do we need to make any change or not? Like this? Yeah, Eric, what's your question? Yeah, I mean, using ruler is fine. Yeah. So here, go to banana. Okay. So here we can use the go to banana directly, just like you go to school. We don't really need a ruler to measure. I'm sorry. Yeah, you need to think about it. Actually, Eric has a good points as well, right? So measure is one approach. So step 20, interesting. So here we have a loop here. Okay, and William, what were you saying? Step 10 again. All right. Okay, so if I try to run it, okay, so the bear act very, very fast, right? Or b dot 1 second playing. So one thing we were saying about this wait, right? It's we want something constant. We want to keep waiting till a condition is happening. So we were just saying in the last challenge, right? So what would you do here? I'm sorry. In the line 3 to 4 until that's right. We want to wait until bear dot sleeping or bear dot playing. Okay, that's what we said. Yeah, it's not just like if. Okay, if it's just like a one-time condition check. Here we actually wanna constantly check, right? Use this until, wait until, right? B dot sleeping or bear dot playing, right? And then we step 10, and then we step another 10, assuming this bear will not catch this. All right, so let's give it a try. That's kind of interesting. So it's waiting for this bear, assuming this bear cannot catch here, okay? So it's waiting for this bear, and then step another 10. All right. Okay. Nice try. Now here, this is for loop when for loop will run first on the monkey, then the goat. Again, we have two tigers. We have monkey and the goats. Now we have a function. Okay, this is a typical function in the coffee script. Okay, where it has its input t. Okay, so wait for, and then in line 2, it's we got to describe. Okay, what we need to do for the wait for, and then when we call that, right, it's like for t in tigers, for stepper in monkey and goats. So we have a looping here. Okay, there are like basically two animals we call stepper. Now we wait for t, and then we say stepper dot step 10. So it's like when it comes to tiger 1, okay, we want wait until tiger 1 sleep, and then monkey will go and step 10, goat will go and step 10. And then the second tiger, again, we wait for the second tiger to sleep or play. Then the monkey step 10, goat step 10. All right. So Wesley, you want to give it a try? Yeah, certainly. So watch for this wait for, okay? Right now there's nothing here. And if we try to run, okay, so notice that it doesn't wait because we need to complete this function related to how do we wait. Mhm, mhm. Right, because yeah, kind of you are on the right point, right? You were saying that we need to wait for, right? So the trick here is that wait for line 7, wait for, okay, this wait for is defined from line 1. So here it's just a way of defining a function, okay, that we can use. So regarding to wait for, like how do we wait? That's the part that we wanna describe that. We want to code it. So the logic, if you see the hint here, right, it says complete me. So we want to put the logic here, okay, in line 3. How would you wait for the tiger? What's the statement that you would use? Exactly. Yeah. So we say until t dot sleeping or t dot playing, right? And then here we're doing our weights. The reason that it has this style is because it's like an until loop. Okay, it's another loop kind of loop in the coffee script that here it's just saying that we keep waiting, okay, until tiger is sleeping or tiger is playing. So now this entire thing is a function, okay, a function. And then the function can be used here, okay, in line 9. So that's how we do that. Think about a function like an aeroplane, okay? An aeroplane, we need to code it. And then once we have the aeroplane, we are able to get a ride on the aeroplane by calling the name directly, okay? All right, so if I run that, okay, so first tiger is sleeping. Okay, good. And we know monkey has to wait and goat has to wait again. Okay, great job. So we've completed challenge 40. Okay, now help the penguins form a bridge for the monkey. Here, the penguins with glasses are closer than those with a bow tie. Okay, so if we take a look here, we have a bunch of penguins. Okay, um, so this one has the glasses, right? This one as well, and then these don't have. So if we take a look on here, right, we have a for loop. So for p in penguins, say p dot has glasses. If p dot has glasses, we want to let penguin to step 15. And now if p has bow tie, like this one, bow tie, okay, bow tie, then we want to p dot step 20. So 20 is about basically till here, right? So the bow tie ones are penguins are further, right? And the glass penguins are closer, around 15 step, right? Okay, so now William, what's your thought here? Go to banana. Okay, let's try that. Now the monkey can get the banana. So we say go to banana, assuming the above are all right. So let's try. So give me a moment here and let me trigger the run. All right. Oh, penguins swim like that. Interesting. Okay. That's very relaxing when you swim like that. Okay, nice. All right. Okay, looks like we have achieved some new mission. Now, glasses and or bow tie define the penguins that should move. Okay, so here for this one, we need to specifically only complete this line. It says for P in penguins, if P dot has glasses, and then let's see. Let me check. Do I have my dark mode on? I don't have my dark mode on. Okay, now Wesley, tell us your thoughts here. We want some specific penguin to move only, right? You are on mute. Mhm, mhm. All right. So we want specific penguin, right? We not this penguin, not this, and not this. So it needs to have both the glasses and the bow tie in order. Yeah, right. So you are on the right track. And if we run that, so let's see, run, right? So only these two penguins can move. All right. Oh, the map. Oh, okay, sure. Let's take a quick look on the map. And so if I come here, all right, yeah, looks like we're pretty close. Yeah, we have maybe another three or another, yeah. So penguins yeah, with glasses and a bow tie should move 9 steps. Other penguins should move 14 steps. Okay, William, give the shot here. So you mean get rid of the say? Okay, and then what? If, okay. Okay, 1 second. Okay, so we say this. If P dot has glasses and P here dot has bow tie, okay, we wanna do what? Let's see, is it a step or is it step 9? Okay, all right. If you look at the statement, okay, here it says move all other penguins 14 steps. What would you do? So here we would just need to, we have it here, right? So else, right? So I just need to put else here, and then else what? Okay, so all right, let's try that. Oops, 1 second. So let's double check. Okay, what method does Penguin have? If I try, oops, we try with for the p dot step. Okay, and let's run that. Okay, so it does listen. That's good. Nice. Okay, cool. Okay, similar stuff. Okay, glasses or bow tie. Here, for P in penguins, check if the penguin has glasses or bow tie. Okay, let's ask Wesley. You are on mute, Wesley. Yeah, so that was just a hint. Yeah, now, okay, okay. Okay, let's see. If P has glasses and P has bow tie, okay, which will mean that these I'm sorry. You mean erase? Run. Oh, okay. Oh, ruler. Oh, okay, okay. 1 second. Ruler. So if we wanna check this one, right? Yeah, P step 10. Okay. Is that's it? Okay. Yeah, we need an or so that any penguin that with a bow tie or glasses, right? They can move. Okay, that's now if we try that, yeah, any of these penguin, right? They will line up like a bridge. Awesome. Okay, good job. Okay, last round is here. So use for to look for the penguins that can help. Those wearing glasses or a bow tie, and then move them 10 steps each time. That's the hint. Okay, so William, you want to give it a shot? Stepper means any animal in the goat monkey. So the goat will run first, okay, and then monkey run. Okay, so if we try run, goat will run right, and then it falls into the river. For being penguin. Okay, so where do we put line 4 or line 2? Line 4. Okay, so for P in penguins, 1 second. So that's for P in penguins. Okay, now what do we want to do? Okay, if penguin what? If P has glasses or P has bow tie. Okay. Okay. All right. So we want to P dot step. Okay. Anything else? Yeah, yes, Wesley. Mhm. Oh, let's double check if we need copy and paste again, okay? Because here we already have another ruler. Okay. So you were saying you want another for loop? Like yeah. Yeah, let's run, okay? Because we have a loop inside a loop. So and let's run, okay? That's what's happening for the penguin. And goat get the banana. Now the penguin get again because this for loop is inside this bigger for loop. All right, good work, guys. Okay, let's see. I think that's the right. That's the coding adventure. Oops, there are some more unlocked. Looks like so. Yeah. So, oh, that's basically coding adventure part 3. So not turns yes to no and no to yes. Okay, this seems pretty straightforward one. Okay, William, you want to give it a try? Okay, let's try. We can only edit this code. We can only edit this code. Yeah, some kind of statement is trying to just distract you. So if we try this, if not banana is green, we go to banana. Okay, that's a pretty easy one. Okay, let's just do another one. Okay, so then that will be it for today. Try out rotten and don't get near those rotten bananas. Okay, Wesley. Yeah. So right. So that's the banana we want the monkey to go and pick. Okay, so here go to B. All right. And if I run that, all right. Yeah, that's right. Okay, yeah, so that's it for tonight. Okay. Anyone have any other questions? All right. Yeah, have a great evening, guys, and we'll see you on Saturday.